All right, well, welcome back. I hope everybody had a good 3-day weekend, a good Labor Day weekend. You've got another 3-day weekend coming up this weekend as well, so have a little bit of time to kind of relax, maybe catch up on some assignments, whatever the case is. A few housekeeping items to take care of. This Thursday, the 6th, that's when you're going to have your next quiz, and it's going to cover the homework we just turned in. So we're going to start a new lesson today. We're going to be looking at graphing rational functions. We're going to start with this very problem right here. But this is not the quiz. It's going to be over sign charts. And to give you a heads up, it's going to be very, very similar to what you did on the test, the bonus question, and the last problem we did in the notes on Friday, where you have to find the common denominator, pull the fractions together, compare it to 0. So you've got to do that algebra before you go ahead and create the sign chart. That's what the quiz will be on Thursday. Okay. Let's see what else. On Friday, I'm not going to be here. I'm going to a workshop. I believe I told you guys. Okay. Mentioned it last week, I think. So what I'm going to do with the substitute, the homework you're going to get for this lesson we're starting today, you'll get it on Friday. So you'll have the entire class to go ahead and work on it. With any luck, you should be able to get it done, help each other out, ask questions. I don't know if the sub will know math or not. Maybe, maybe not. Sometimes you get lucky on that. But you hopefully should be able to finish it. It'll be due on Tuesday. I believe that's the 11th, correct? Okay. Tuesday the 11th when we get back. If you have any questions, come on in for tutorials. The big one I want to go ahead and get you to think about, on Monday the 17th, basically 2 weeks from yesterday, is our next exam, our second exam of the 6 weeks. So I think the first one came back really well. A lot of people did really good. There's more time until we get to the next one, so that means potentially more material on the test. So you don't want to go ahead and wait till the last minute. You'll be thinking about that. So just under 2 weeks, you have your next exam. And I think that's everything I got. Oh, speaking of the tests, I've already passed most of those back. If you weren't here on Friday, I can get those back to you in just a moment. But when is the deadline to retake the first exam if you want to? Okay, Tuesday the 11th. This coming Tuesday by 8:05 a.m., by the end of tutorials. Because this is just an odd week. We weren't here yesterday. I won't be here Friday. And then we're again not here on Monday. So that's why it's going a little further than it normally does. Okay, so any questions? Anything about the quiz, the test, what's going to happen on Friday, any of that good stuff? Sounds good. Let's get started. Now, we want to go ahead. Our goal is to graph these functions today to get a sketch. We want to label everything. So these questions are what you should be asking yourself when you're analyzing a function, because we want to know where are all my asymptotes going to be. Does this guy have a hole? Is there a removable discontinuity? What are my intercepts, if any, both x and y? So here's the first question. What's the equation of the function written in completely factored form? Okay. So let's start with the denominator, because that's a simple trinomial. X squared plus 4x plus 3. So here's my quotient. What two numbers will multiply to give me 3 but add to give me 4? Okay, 3 and 1, right? That's easy. So x plus 1, x plus 3. Now the other one, you're probably going to want to use some kind of strategy. Maybe you were taught guess and check, where you just plug in numbers until you have a combination that works. Anybody like the grouping method? Say some people like grouping. What about the box method? Some people like the box method. I want to go ahead and emphasize, if you have a method for factoring trinomials and you feel comfortable with it, absolutely go ahead and continue to use it. I've got a method that I like. I've been using it for a very long time. It's called My Father Drives a Red Mercedes Convertible. And I'm already getting some strange looks, okay, which is actually not true, because my father drives a maroon Ford pickup, but that's something different. But if I were to say, please excuse my dear Aunt Sally, what does that mean to you? PEM does. It's your order of operations, right? Parentheses, exponents, and so forth. Well, my father drives a red Mercedes convertible. Every letter of each word is a step in the process to factor these guys. So if your trinomial can be factored, it's going to break it apart. Doesn't matter if it's simple, general, perfect square, whatever. Okay, it's always going to work. It's a universal method. So I'm going to go ahead and show you this very quickly. Some people have liked it today. Some people have said, no thank you. And that's perfectly fine. But does anybody know what it factors to? So I can show that it connects. Satish, what do you think? Okay, he's absolutely right. He says 2x minus 1 and then x plus 3. That is exactly what that trinomial is going to factor into. Okay, so let's go through the process real fast. Okay, so my. The M in my stands for multiply. Multiply. So I'm going to multiply the leading coefficient by the constant. So 2 times negative 3 will give me negative 6. Okay. That's all you got to do for the first step. Now, the second step, this is the most crucial in the entire process. If you get this step right, the rest of it goes fast. Guaranteed you got the answer. So it's my father. So we factor. So you've got this product here. Okay, what two factors, two numbers, will multiply to give me negative 6, but add to give me 5? And one of them has got to be negative because we got a negative 6. What are we thinking here, Aiden? Positive 6, negative 1. Perfect. Like I said, that's the most crucial in the entire process. If you get those two numbers right, the rest of it goes quickly. Okay, so my father, we multiplied and factored, drives. Now we divide. Okay, so the factors I found, we divide again by that leading coefficient. In this case, it's 2. But remember, every polynomial is going to have a different leading coefficient. So you won't always be dividing by 2. Okay, so I've multiplied, I've factored, I've divided. Okay, so my father drives a red. The R stands for reduce. Basically, simplify. Can we simplify 6/2? Yes, the only trick to this strategy, you want to leave it as a fraction. Because we need both the numerator and denominator to create my binomial groups. So 6 divided by 2, I'm going to say that's 3/1. And negative 1/2 will not reduce, so it stays the same. Okay. So my father drives a red Mercedes. So this second M stands for move. This is where you get your factored version. You take the numerators and the denominators and you use those to create your binomial groups. But you always start with the denominator. So for like this first group right here, the denominator is 1. That's the coefficient of my variable. So this is going to become 1x and then plus 3. And then negative 1/2, starting at the bottom, you can see how it becomes 2x minus 1. And there you go. Okay. Now, once you get accustomed to it, it's really fast. It's really nice. Every time I'm going to factor a trinomial, I'm going to go ahead and use that method. Okay, if I can't see it right off. Okay, if you don't like that, great. If you do, fantastic. Would anybody like me to go ahead and put a document talking about this on the website? A few folks? Okay, so I'll go ahead and do that. All right. Has anybody ever heard of that before? Nope. Okay. Scholar. Yeah, Scholar. Didn't I show you guys that at Scholars? Yeah. Okay. So there's one other thing, though. My father drives a red Mercedes convertible. What do you think that last C stands for? This is the one that typically people don't want to do. Check. Okay. Because when you factor, you should always be able to check to see if it's right. You can multiply those back and see if you got the original statement. But I'm not going to worry about that. If you multiply those, yeah, you're going to get that. Okay. So there we go. Just to kind of show you very quickly. All right. If you like it, great. If not, if you like your own method, I encourage you to use it. All right. Now let's talk about vertical asymptotes and holes. So let's go ahead and start there. Are there any holes in this graph? Heard a yes. How do I know? Okay. If you have a common group factor that'll cancel between the numerator and the denominator. So that tells me, yes, there's a hole. If there's nothing that cancels, then there's no hole. So I'm still going to take that group, x plus 3, and I'm going to set them equal to 0. And you're going to notice there's a lot of similarities to what we did with sign charts. The undefined values are still coming out of the denominator. The zeros are coming out of the what? The numerator, okay? So x equals -3. So I know the whole is going to be located at x equals -3, but I want the location. I need the y value that corresponds to that. And we've mentioned it before. Does anybody know what I would do? Erica? There you go. That -3, the value of x we got, plug it back into every x that did not cancel. So 2x minus 1 becomes 2 times -3 minus 1. X plus 1, -3 plus 1. So 2 times -3 minus 1. -7 over -3 plus 1. -2. And the only thing I can simplify are the negatives. So it should be a positive 7/2. Or 3.5 if you want to go decimal. That's perfectly fine. So I have the location of my whole, what we call a removable discontinuity. Okay. So does that mean -1, the other value, he's going to be a whole too? What do you think? Yes or no? No, but he came out of the denominator just like -3. He didn't cancel. There was no x plus 1 group that canceled. So he's got to be a what? He's a vertical asymptote, or what we call an infinite discontinuity. So x plus 1 is equal to 0. So x equals -1. So VA, we have a vertical asymptote at, and always give me the equation. Just don't go ahead and say vertical asymptote is -1, because that will result in point loss. You want to give me the equation for the vertical and the horizontal. Okay. All right, good. Anybody confused on anything we've done so far? Basically very similar to our sign charts, right? That's why I like to go ahead and start with those. Now, if any exist, identify the horizontal asymptotes. Okay, so basically, will this have a horizontal or will it have a slant? Do you guys remember what we called the slant asymptotes? Oblique. So what do you think, horizontal or oblique? Oblique? Okay, who said oblique? Jack? How many people are going to agree with Jack? Okay, Skylar has his back. Okay, unfortunately, we are not correct. There is a horizontal. What do we look at to help me figure that out? The exponents. What do we call those? The degrees. Now, there's 3 cases. Either your degrees are going to be the same, or the numerators will be larger, or the denominators will be larger. So I've already got these written out right here. Okay. So if the degrees are the same, you divide the leading coefficient. Now, these are the shortcuts. I'm going to be going back once the problem is over. How many people are planning on going into calculus, whether BC or AB? Okay, so once the problem is over, I'm going to go back and show you how you're more than likely going to be required to write these in there. I'm not going to hold you to that. Okay, but if the numerator's degree is larger, you got to use long division. That's when you have an oblique asymptote. You have a slant asymptote if the numerator's degree is larger. Or instead of long division, anybody remember what's the shortcut? Synthetic. That works out just as nice. Probably a lot faster. Synthetic division. If the degree of the denominator is larger, then you don't have to do anything. The x-axis, y equals 0, will be your horizontal asymptote. Okay. So it's either going to be the x-axis, you'll use longer synthetic division, or you'll divide the leading coefficients depending on how your degrees relate to one another. So I'll give you another few seconds to write that down. So looking at this function, what's happening? Are they the same? Numerator larger, denominator larger? Okay, heard somebody say it. They are the same. They both have a degree of 2. Okay. All right, few more seconds. All right. Okay, so we know there is a horizontal asymptote at what? y equals 2. There you go. The leading coefficients are referring to the coefficients on the terms that have the largest degrees, the largest powers. So here I would take 2 divided by 1, so yeah, it's at 2. So a horizontal asymptote at y equals 2. And just like the vertical asymptote or asymptotes, make sure to give me the equation, not just the value. Okay, y equals 2. All right. And now we want to talk about the zeros. So this is where, if anywhere, the function may or may not cross the axes, the x and the y axis. So let's start with the x-intercepts. Okay. Well, does anybody remember we called these zeros? How did we find them when we were looking at sign charts? Say what? Susie? Say one more time. You're absolutely right. Now, there's something we'd cancel, so the shortcut would be to set what equal to 0. Starts with the n. The numerator. But she's not wrong. If I were to go ahead and set the original function equal to 0, well, if you're solving for x, we want to go ahead and get rid of the fraction, right? So I'd go ahead and multiply both sides, x squared plus 4x plus 3. X squared plus 4x plus 3, because those are going to cancel. And what's 0 times anything? Yeah, it's still 0, right? So this is why we have the shortcut that you set 0 equal to the numerator. We've already taken care of the denominator. But what's the only thing left in the numerator? Again, go to your factored version. We already took care of the x plus 3. We know he's the whole. So I'm going to take 2x minus 1. Set him equal to 0. So x equals what? 1/2. But again, just like the whole, actually give me the location. Write out the coordinate. Connor, you okay? All right. So there is an x-intercept at 1/2, 0. Now, it doesn't mention it, but I do want you to go ahead and find what? Saul, what do you think? What do you think, Saul? You're not sure? It does help if you're awake. Okay? I need you to stay with me, man. Okay? Take out your pencil. There we go. All right. Yeah, the glasses help too. There you go. Let's talk about the y-intercept. Now, there is a shortcut here, but think about this. Any value you take on the y-axis, what is x always going to be? X is always going to be 0, right? So there's a couple of ways you could do this. Y-intercept. Okay, so let me go back over here. Well, if you're looking for the value of y when x is 0, maybe you just want to go back to the original on this one. Okay? Because think about it. What's 2 times 0 squared? 0 plus 5 times 0? 0 squared plus 4 times 0? All you're left with are your constants because every x drops out. That's the shortcut for finding those. Divide your constants. Okay, so here I'll go ahead and say the y-intercept. I'll go ahead and take this off right here. Let's see if it'll let me do this. Perfect. Okay, so -3 divided by 3. -1. So my y-intercept should be at 0, -1. Perfect. Now, I'm more interested in the domain than the range. We can go ahead and list it if you want, but we'll go ahead and get that once we have the sketch. For a lot of people, it's much easier to find the domain and range when it's in front of you, the visual. Excuse me, because this is a lot of information right here. So, very quickly, before we get to the sketch, is there anything we don't know where it came from or we don't know how we got it? Anything we want to recap? Okay, then let's take all this information and put it together. So my vertical asymptote was at -1. All right, so on this grid right here, let's start, here's -1. Okay. Now, where was the horizontal asymptote? 2. Now, here's the thing on this. You don't want to draw the horizontal asymptote all the way through. Same with slant asymptotes. We want to draw what we call the ends. So I want to draw the left side, and I want to draw the right side. Okay, now here's why. You're only going to approach the horizontal asymptote or the slant asymptote as x becomes increasingly large or small. You'll see this when I show you how to write it for what you're going to do in calculus in a second. Okay, basically what I'm telling you is that around the origin, that horizontal asymptote doesn't exist yet. Okay, now you can go ahead and draw it all the way through. That's not going to be a problem, but you might occasionally run across a graph that might look like he's going to cross the asymptote, and we know they'll never intersect. Okay, so you may just want to keep that in mind. It's very, very possible for that to happen. All right, so like I said, I'm not drawing the middle, I'm drawing what we call the ends. All right, where was the hole? Okay, it was -3 and then 7/2. So -3, 3.5, so I'm going to put my hole right there. That's the ordered pair that I'm removing because we had a common group factor. What were my intercepts? Okay, I'm sorry, what was that? Who's it? Okay, 1/2, 0. So 1/2, 0 right there. And the y-intercept was 0, -1. Okay. So here's all the information we found by analyzing this rational function. Now, we have to figure out where my curves are going to go. And this is a pretty easy graph to look at. On the right side, okay, to the right of -1, in this whole area right here on the right, where do you think my curve is going to be? Above or below the horizontal? Right below. There you go. Look for where your information is falling. I've got these two intercepts below the horizontal. So that means as x approaches positive infinity, he's going to approach 2, but he's going to approach it from below. Maybe 1.8, 1.9, 1.99, 1.999. He's going to get really close, but he won't ever touch it. Okay. Where do you think the branch will be on the left, above or below? Above, because that's where we have my hole. Okay, the 3.5 is definitely bigger than the 2. But now here's where there's a slight difference. As x approaches positive infinity, you are going to approach 2 from below. As x approaches negative infinity, he's still going to approach 2, but from what direction? He's going to approach it from above. So maybe 2.1, 2.01, 2.001, and you just keep getting closer. Okay. And there you go. We got a pretty good sketch. Now let's say this is what you turned in on maybe a quiz, on maybe a test, whatever the case is. Would this get 100%? No. I mean, the graph does look pretty good, but what am I forgetting? Now we don't need any more points, but we have to label those that I have. Label everything that you find. So this hole, we found him to be at -3, 7/2. The x-intercept was 1/2, 0. Y-intercept was at 0, -1. We already labeled the asymptotes. Okay, we got a pretty good idea of what our function is going to look like. So that would get 100%. Okay. I mean, you can put more points on there if you want, but it's not necessary. All right, and there we go. What would his domain be? Well, it's obvious these guys are infinitely wide, so we are going to go from negative to positive infinity. But are there any values of x that we have to throw out? The -3, because he belongs to the hole, and -1, because he's the vertical asymptote. So what would that be? Negative infinity to what? To -3, union. Oh. Then we want to go -3 to -1. Then we'll take it up -1 to infinity. Because if you were looking on your sign chart, if you were to create one, okay, you would go ahead and put 3 values on there. You have 2 undefineds and 1 0. So it'd be -3, -1, and then 1/2. Okay. So it's breaking it up into 4 parts, 4 regions. And I'm going to keep emphasizing that because the sign chart is telling you everything that's happening graphically. And now we're to the point where we're graphing these guys. Okay, good. Now let me go ahead and quickly show you how we would do this in calculus. I'm going to erase everything except the factored version because I'm going to use him in just a second. Okay, so you may or may not know about this. I would imagine Mr. Heinrich would have brought this up in Algebra 2 last year. How many people had him for Algebra 2? Then you're probably going to recognize this. There's a form that we call reduced form that I'm not going to go ahead and make you run through, but this is probably something that could happen in calculus. What you're going to do is take all of the terms you have. So I have 6 total in the original function, and I'm going to divide them all by x to the degree, whatever the degree is. So here I'm going to divide all these by x squared. So for example, what is 2x squared divided by x squared? 2 plus 5x over x squared. That's 5 over x minus 3 over x squared. Is this looking familiar? Did he show you this? Okay, you think so? Okay. X squared over x squared would give me what? 1 plus 4x over x squared, so 4 over x, and then plus 3 over x squared. Now, the way it would be written, because for the horizontal asymptote, you're trying to determine what the graph is going to approach as x becomes extremely large or small. So as x approaches positive or negative infinity, y is going to approach. So imagine if I were to take every x, whether squared or not, and I replaced it with infinity. And it doesn't matter positive or negative. Okay. What happens to the value of a fraction as the denominator becomes larger? It decreases, it gets smaller, right? So if the denominator becomes infinitely large, then the value of the fraction becomes infinitely small. Will it ever equal 0? No, technically not. Now, it's going to reach a value that is so insignificantly small that we kind of just throw it away. We ignore it. We say it might as well be 0. But all of these guys right here will go to 0. And you'll notice, what do you have left? 2 divided by 1, which is your horizontal asymptote. Okay? So that's the way you would actually write it out. Now, for the vertical asymptote, you would do something a little different. You need to go ahead and approach it from a specific direction. So let me go ahead and get this domain out of the way. All right. If you see, like in this case, our vertical asymptote is -1. Okay. In the place of a power, if you ever see a positive or a negative symbol, like this, what that's telling you is the direction you're approaching that number from. So if I see -1 with a plus, then I'm approaching him from what? From the right. Okay, the negative, I'm approaching him from the left. Okay. Now here, okay, these guys are going to have no boundaries. So as they get closer to the vertical asymptotes, they only have one of two choices. They're going to want to curve up forever, or they're going to curve down forever. So your answers here for the vertical asymptotes are only going to be positive or negative infinity. So let's test one of these. Okay. You would say, as x approaches -1 from the right, well, what's the function doing? Okay. Now, what I like to do, and every teacher is different, I'm not sure how Mr. Heinrich, for example, likes to do this. I like to choose a value to the immediate right and left of my vertical asymptote. I go within 1/10 of a point. Okay. So what's 1/10 of a point to the right of -1? That'd be -0.9, right? Did he? Okay, good. What would be on the left? -1.1. So don't choose the value itself, because we know what's going to happen. It's undefined. So we choose a value that's extremely close. And again, it relates back to your sign chart. I'm not interested in the number itself. I only want to know, is it positive or negative? Now, when we looked at our factored version, Remember, there was only two groups left, 2x minus 1 and x plus 1. So I'm going to come back over here. So 2x plus 1 and x minus 1. Was that right? Plus 1, I'm sorry. Okay. So now I'm going to replace those x's with the value of my choosing. So I'm going from the right. So 2 times a negative 0.9 plus 1 over negative 0.9 plus 1. And again, I'm not interested in the number itself. I just want to know, would it be positive or negative? So 2 times a negative 0.9 plus 1. That would definitely be a negative number over negative 0.9 plus 1. That would be a positive. So what's a negative divided by a positive? A negative. So as we approach negative 1 from the right, we'd want to go to negative infinity. And look what happened on the right. What'd he do? He wanted to curve down. So if I were to do the same thing, if I took the negative 1.1 on the left to finish up this statement here, what should I be getting? Should be getting a positive infinity. So he did cover that? Okay, very good, very good, very good. More than likely, that's going to make a comeback when you get into calculus. So I'm just kind of throwing it out there. I'm not going to hold you to writing those down. I probably should, but we're at the review stage. I just want to get through these items as fast as we can because we want to spend a lot of our time on trigonometry. That's what the majority of our year has to be. Okay, so any questions on a rational function? How are we doing? Ready for another one? Yes. Okay, let's do it. Yay. Let's see here. Let me go ahead and take this off. Now, this one's going to go a lot faster, one, because we already know what it is we're looking for. We're going to use the previous one as a template. I'm not going to worry about showing you the calculus notation on this one. We've already done the factoring, so not a whole lot left. Right, Xavier? Okay, wake up, man. Okay, you guys got to stay awake. Okay, let's go ahead and take a look at this one. Can I factor it? Okay, so the first one isn't factorable, the x plus 2 is a prime binomial. What about the other one? X plus 2, x plus 4, there we go. So we didn't need any fancy strategy to get him. He was a simple trinomial. Okay, so let's start here. Okay, Shayna, yes or no, is there a hole? Yes. Okay. Ethan, how do we know that? Okay, we had a common group factor that cancels. So we didn't do this on the last one, but you can rewrite it again. It's just 1 over x plus 4 if you want to. Okay, so I'm going to take that group that canceled. I'm still going to set him equal to 0. So x equals what? Negative 2. So I know that we have a hole at negative 2. Simeon, how do I find the y value that corresponds to it? What do I do? Don't remember? Okay. Raphael? Okay, he says plug it into all values that aren't canceled. We've only got one x left. So this would be 1 over negative 2 plus 4. So what would that be? 1/2. Perfect. Okay. So you get the x from the group that cancels. You take that x and plug it into every x that's remaining. Now, if no group cancels, well, then you don't have a hole. You don't have to worry about that. Okay, perfect. Now, do we have any vertical asymptotes? The x plus 4, because he didn't cancel, but he still makes the denominator 0. In fact, what value of x am I referring to? Negative 4, right? Okay, so I have a vertical asymptote at x equals negative 4. Remember, got to give me the equation, not just the value. Okay. Horizontal or oblique? Remember, that was just slant. Miriam, what do you think? Horizontal or slant? Horizontal. There we go. Let's take a look. Now look at my degrees. What's the degree of the numerator? 1. The degree of the denominator is 2. So I'm going to come on over here to my 3 cases. If the denominator's degree is larger, we will have a horizontal, but where? Y equals 0, the x-axis. Okay, the only time we're going to have a slant asymptote is if the numerator's degree is larger. Now, technically, if it's 1 larger, okay? If it's, say, for example, 2 larger, you could have a quadratic asymptote. Is it possible to have an asymptote in the shape of a quadratic? Absolutely, yes. Okay, now we're not going to be looking at those, but it could happen. All right, so we have our horizontal asymptote at y equals 0, the x-axis. What is or are the zeros of the function? Okay, so what was the shortcut for the x-intercepts? We've already taken care of the denominator. Okay, what values of x make the numerator 0? Could I go ahead and say -2? Some people are shaking their head no. Why can't I use -2? It's making the numerator 0. But it also makes it undefined. Remember, it canceled. We've already labeled him as the whole. So what's left in the numerator that I could set equal to 0? There's an x left? Now, see, we only had the one group, and it canceled, so I have 1 over x plus 4. So there is no x remaining to set equal to 0. So what would you say about the x-intercept? Jacob? There is not one. That's right. X-intercept. Now, it stands to reason the x-intercept in this case is also a what? Is also a horizontal asymptote. Okay, but remember, just because the x-axis is the asymptote, does that automatically mean that we will not have an x-intercept? Remember, what did I say about the horizontal and the slant asymptotes? They don't exist where? They don't exist around the origin. So it is very possible that could still happen. Okay. What do I do for the y-intercept? Okay, we can plug in 0 for x. So that would be 0 plus 2, 0 squared plus 6 times 0 plus 8. Okay. So what's my y-intercept? 1/4. Or even if I were to plug 0 into the factored version, would I still get the 1/4? Yeah. 0, 1/4. Okay. There we go. Questions? Okay. Well, are we ready? Do we have? Oh, Jack. Yes.
Well, I mean, just kind of either jumping in or coming back.
Okay.
It says on the graph, you use an analysis like almost 3 points on each branch.
Oh, I'm not worried about that.
Okay.
Yeah. The resource I got that from, I mean, because I'm thinking from this, if you want to go ahead and put additional points on there, I would think all we need to do is just create a T-chart or even use technology. So we're still getting a really good representation of the graph without doing that. So I'm okay. Yeah, that's a good question. Okay. All right, well, let's go ahead and put all this together. In fact, why don't you go ahead? We still got a good 3 or 4 minutes. We have time. Draw what you think this guy looks like. Okay. And then I'll catch up to you in just a second. Probably won't have finished by the time I start drawing, and that's okay. We're just about to run out of time. We got it 52, right? Yes. All right. Let's see here. So I think I might need your help on this one. Would everybody agree with what I've done so far? We got y equals 0. We got x equals -4 for my asymptotes. I've got this hole at -2, 1/2. I have the only y-intercept at 0, 1/4. And see, I knew to go ahead and draw the branch above because that's where my points were with respect to the horizontal asymptote. But what's happening on the left? See, I don't have anything. Okay, this is where you want to think about what we did on a sign chart. Okay. So what are the values that you would have put on a sign chart? -4, definitely the -2. Okay, because those are the only values that came out of the denominator. Now I'm only interested in this interval because I can see what's happening in the rest. So what you'd want to do is choose a value and plug it in just like we did last week. Okay. So anybody who's done that, can you tell me, is it above or below? It is below. You should get a negative number. So it should look something like this. Okay. How we doing? Any questions? All right. Thank you very much, guys. We got just in